Alright, what I want you to do is go ahead and copy this down. So go ahead and hit pause. We are talking about 11.7 and 11.8 three-dimensional figures. The reason we're doing two sections at one time, just a little, both of them were fairly simple concepts to understand, and they both are related in many similarities. So just for time's sake, we're going to combine these. A couple things we need to know and understand about this are these three items: faces, vertices, and edge. Faces are its surfaces, and we have a front and a back, a right side, left side, and then a top and a bottom. Total of 6 faces. An edge is where two of the faces connect. So we have 1, 2, 3, 4 edges on that side, 4 on the other end, and then the length connecting those tops and bottoms and the front and back sides, we also have 4. So a total of 12 edges. Vertices are where 3 faces connect and it creates a point, and those are what we call, again, vertices. So we have 4 on that side and 4 at the other end, with a total of 8. Okay, and we're going to talk further about that tomorrow. Go ahead and hit pause and copy down this information. Now, on a prism, it has at least 3 faces that are rectangles. At least 3. The top and the bottom faces are the bases and are parallel. The shape of the base tells the name of the prism. Okay, so 3 faces that are rectangles, at least 3, and we do have that in this case. Again, we name them by their base. They have to be congruent surfaces, top and a bottom, and they are parallel. So the top and the bottom would be my base. Now if we were to tip this on its end, yes, then maybe the right side and left side, which would now become our top and bottom, they could also be considered that. So a rectangular prism could have many different bases for that particular shape, but not all of them are. So again, since it's rectangular, we could also call it a square prism as well in this case. Rectangular prism, triangular prism. Many students want to call it a rectangular prism because most of the shapes are rectangles, but that is not the case because they have to be parallel to each other. Okay, the triangles are what are parallel to one another. The other 3 sides that are rectangles are not parallel to one another. So it is a triangular prism. And then this last one, we can call it a square prism, but you can also call it a cube, just because it has all congruent sides and edges as well. Okay, so go ahead and make certain that that's copied down. Go ahead and hit pause and copy these down as well. Now for a pyramid, it has at least 3 faces that are triangles and only 1 base. This is the difference between a prism and a pyramid. The base can be shaped like any closed figure with 3 sides or more, and then the shape of the base again tells the name of the pyramid. So one of the things you need to know too is that usually opposite of the base is going to be the point that all of those sides come together on, excluding the base. So it's usually always opposite of it. This is their triangular pyramid, and again, because it's base and there's only one, it has a triangle for its shape. For this one, we call this a rectangular pyramid, or you could also call it a square pyramid because it does look very similar to being a square. And obviously, if we had actual units of measurement on here, you could easily determine that. But it does come to a point, and you can see that there are more than 3 surfaces that come together for that as well. And it comes to that point. Pyramids are usually a pretty easy concept to understand and identify, mostly because of the studying that you've done with the pyramids in Egypt and so forth. So, but that's exactly what those are. Some specific, more detailed types of shapes that we have, three-dimensional figures that don't fall under the pyramid and prism category, would be a cone. Okay, has only one base. The base is a circle and has only one vertex. And when you think about that, it does. It's only got one point. A cylinder, it has two bases, the top and the bottom. The bases are congruent, circles. They are equal to each other. And has no vertices or edges. It doesn't have any. Okay, and you say, well, this has an edge. Yeah, it does when you're looking at it from a two-dimensional standpoint, but that is all round. And a sphere, like our planet Earth, why we call them hemispheres, that's where that name comes from. All of the points on a sphere are the same distance from the center. Okay, they're all the same distance, and no matter where we go from. It has no faces, no bases, edges, or vertices. It has none of the above. That's what makes it so unique. Okay, so go ahead, you can write those down if you haven't already. So now we're going to draw a top, a side, and a front view of each figure. So what we have to do is identify which one's what. And some students coming in from this direction say, well, that's my front, and this is my side, and that's my top. It depends where you're looking at, okay? So it doesn't matter how you do it. I'm actually going to look at this figure coming in from this view, and I'm going to make this my front. I'm going to make this my side, and I'm going to make this my top so that you can understand what we're looking at. Okay, and it is best to use a straight edge for doing these shapes. When I look at this particular front, you're trying to match it up with this and have that same length, and only look at what that face is actually looking at. You're just looking at this two-dimensional figure. So it is a rectangle. So draw that rectangle. So that's my front. And then I'm looking at my top. So if I'm looking down on it, or if you're looking at it three-dimensionally back behind there, you could as well. But usually you're looking down on this top of this figure, which is going to be very similar to that. And you can see how long this line is and how long that line is. So it's going to be pretty much the same shape. And you can just kind of judge it by what it's looking like and appearing to be. There's the top and my right side. And if this was more elongated, you could make it a little more elongated, saying that that's a longer side. And by looking at that, and you can see that that's the same height, but it might be a little bit longer than some of the other ones. So we'll make it a little bit longer just to express it. So there you go. And again, this would be my front, this would be my top, this would be my side. Okay, and it obviously gets a little more detailed once we do some different shapes besides a rectangle, and we'll do one on the board tomorrow. This is a cone. This is where you're going to say, all right, this doesn't make sense. So let's take a look at this. And remember, for my front view, I'm looking at it straight on. And what does it create when you look at this straight on? Okay, and think about what happens when you look at it from coming in from the right side and what you're looking at when you're looking straight down. So go ahead and hit pause and try this. Alright, now what you see looking at this shape, if you were to cut this off, it's really not even going to be rounded because you're looking at it straight on. It's almost a line going straight across. So you're basically creating a triangle. Okay? It's a triangle that you're looking at. And the side view, Same thing. You're looking at a triangle. It doesn't matter what angle you look at this, from this side or front side, all angles around this, you're going to see a triangle. But looking down upon this, what are you going to see? Well, when you look straight down on it, it is going to just be a simple circle. Okay, and the vertex would be right there in the center. So that is what you're looking at for my front, side, and top. And I know that I flipped those around, these two. You can put them in any order that you prefer. So don't fret that you think you have to have it in the right order. Now, for the difficult part, and I say difficult, this is always, it's called dot matrix paper, and it's always a little more difficult for students to draw and understand what this is actually doing. Well, it's helping you create a three-dimensional figure. Well, the best way is to start with the top, okay, and draw the top and know that you're going to be working down from there. So make sure certain you work more towards the top of that page. So it is 1, 2, 3 blocks long. I'm going to draw this line right here, and you're going to draw it at an angle. So there's 1 block, 2 blocks, 3 blocks, okay? And then I'm going to draw this line, and I'll draw it down towards here, and it's 3 blocks long. So 1 block, 2 blocks, 3 blocks long. And you said it was 3 long this way, so there's 1, 2, 3. And you can start to see how this is becoming that shape. And since it's 1 block long that way, I'm going to bring it back this way and bring this one back this way. That's going to create these lines right here and right here. And then I've got to bring it back, and it's bringing it back 1, 2 spaces. So bring it back 1, 2, bring this back 1, 2, and then connect them. And you can see that it creates this same shape, but it's on an angle. Well, now we're making it three-dimensional. And by the way, this is incorrect. This actually needs to be, I'm going to draw these in. It needs to be 1 more block long. Some reason it won't let me save it on there, so I apologize. That needs to look just like this, actually. They look just the same. So now you're going to look at my side. So this is going to help me see, and I'm looking at just this side, and it would be this side right here, trying to determine how tall it is. And I see it's 1, 2, 3 tall. So let's bring it down 1, 2, 3 blocks. 1, 2, 3 blocks, and then we'll connect it. Okay, that's that side. And if you want to draw in all those little blocks, okay, because it's like cubes that we're going to be drawing, you can do that as well. Okay, and these are cubes here. You're just connecting them all in an angle because it's three-dimensional. And then we're going to look at the front, which is this one, and it is 1, 2, 3 long, 3 high, which this is my 3 long, this is my 3 high. So we're going to bring it down 1, 2, 3, and then bring it over 1, 2, 3, and now we can connect all of our lines and connect them here, and you can see the cube. Now one little last detail is we can bring this line down to there, this line down to here, and you can see how it creates that cube. And I goofed a little bit here. This line needs to go down to that, and this goes to there, and you can see those cubes. Okay, sometimes it's a little easier if you just leave them out of there, and you can see that that's hollow, but ultimately this does come down and that comes down, and you can see those hidden blocks. Okay, and this is open right in through here. Okay, we'll work on this. This takes a little bit of time, and it's practice. And that's the best way of doing it, is just to practice some of these, and we'll be doing those for our assignment tomorrow, just to have fun with it and see what the shapes that you can come up with. Some of the students, it's a real difficulty, but it's okay. We'll work through it. Again, take note, and we'll talk further about this tomorrow. Have a great evening.